Hello dear students of class 2 medical and non-medical respected teachers. So in this video I am going to discuss transformer. What is transformer, what is its principle, construction, working and theory, and what are its uses and what are the various losses in transformer, everything. So let us start. What is transformer? Transformer is a device which increases or decreases voltages, AC voltages. Transformer is a device which increases or decreases AC voltages. Principle. It is based upon the principle of mutual induction, which states that when magnetic flux linked with the primary coil changes, induced EMF is produced in the secondary coil. So this is principle of mutual induction. Construction. Basically, transformer is of two types, step up transformer and step down transformer. Step up transformer increases voltage, whereas step down transformer decreases voltage. So suppose we have a large number of metallic sheets, rectangular metallic sheets placed one above the other and well insulated from each other, that is laminated soft iron core, and the shape as shown in figure. One arm of this cubical structure, a primary coil made up of copper, well insulated from the frame, is inserted and it is connected to the input AC source. On the opposite side, there is secondary coil and which is connected to a load across which output is taken. Both primary and secondary coils are well insulated from each other and they are placed in such a way that magnetic flux linked with primary is also linked with secondary. Suppose N is the number of turns in the primary and S the number of turns in the secondary. In case of step up transformer, number of turns in the secondary is more than number of turns in the primary. And in case of step up transformer, voltage across secondary is more than voltage across primary. Reverse is the case in case of step down transformer. So when this alternating source of EMF is switched on, current varies in the primary coil continuously and hence self-induced EMF is produced. And magnetic flux linked with the current also changes. And this magnetic flux linked to the primary is also linked to the secondary. That is, magnetic flux linked to secondary also changes. As a result, we get output across the load. Theory. Now, alternating EMF across the primary is given by EM sin omega t when it passes through a pure inductor, and IP is equal to IM sin omega t minus pi by 2, because when AC is passed through a pure inductor, alternating current lags behind the EMF, alternating EMF by pi by 2, or you can say alternating EMF leads the alternating current by pi by 2. So power dissipated in primary coil is 0 under ideal conditions. Under ideal conditions, so IP, EP, if whole of the magnetic flux linked to primary is also linked to secondary under ideal conditions, so IP, EP, that is power, input power must be equal to output power, or ES upon EP is equal to IP upon IS. So this is under ideal conditions. By Faraday's law of EM induction, EP is given by NP d phi by dt, NP number of turns in the primary into rate of change of magnetic flux, and ES is equal to NS d phi by dt numerically. So divide pi by 4. So we have ES upon EP is equal to NS upon NP, and comparing 3 and 6. So we have ES upon EP is equal to IP upon IS is equal to NS upon NP is equal to K. Where K is known as transformation ratio. So this gives relation between input and output currents and number of turns of primary and secondary. So for numericals, you have to remember this relation. So for simple numericals of transformer, so K is known as transformation ratio, which defines the ratio of number of turns in secondary to number of turns in primary, or number of voltage across secondary to the voltage across primary, or current across primary to the current across secondary. So transformer is of two types, step up and step down. What is the difference between step up and step down transformer? Step up transformer increases voltage by decreasing current, whereas step down transformer decreases voltage by increasing current, because IPEP is equal to ISES. Number 2, as ES is greater than EP in case of step up, therefore IS should be less than IP because product remains the same. In a step down transformer, ES is less than EP, it decreases voltage, so therefore IS should be greater than IP. Third point of difference, number of turns in secondary are more than number of turns in primary in case of step up. In step down, number of turns in secondary is less than the number of turns in primary. Fourth point, since IP is greater than IS in case of step up transformer, input current is more than output current. So to avoid heat loss, so primary is made up of thick copper wire, secondary is made up of thin copper wire. Whereas in case of step down, reverse is the case because IP is less than IS. So secondary is made up of thick copper wire, primary is made up of thin copper wire. Fifth point of difference is transfer ratio is greater than 1 for step up, for step down K is less than 1. Then what is the efficiency of a transformer or in idle case? So efficiency is defined as the ratio of output of transformer to the input of transformer, which is equal to 1 or 100% for idle case under idle conditions. But practically there are so many losses in transformer, energy wastage, so efficiency is always less than 1, that is always less than 100%. What are the various losses in transformer? Number 1, copper loss, because copper has some resistance, then due to joules of heating, some heat is lost, so that is called copper loss. So this copper loss can be minimized by using thick copper wire up to a certain extent. Then iron losses, since eddy currents are produced in the frame which is made up of soft iron core, even we use laminated soft iron core, but we can minimize these eddy currents, loss due to eddy currents, because eddy currents will also produce heat. So by using laminated soft iron core, it can be minimized, but it cannot be made zero. Third, there is a magnetic flux leakage, because whole of the magnetic flux linked to primary must be linked with secondary. So, but practically some magnetic flux is wastage, or it gets leak from the primary coil, it doesn't reach the secondary coil. So to avoid this magnetic flux leakage, so transformer of special shapes are preferred. That is, in case primary and secondary are wound on soft iron core having same axis one above the other, but well insulated from each other to avoid leakage of magnetic flux. Then hysteresis loss, because when we apply AC source, AC voltage which increases, decreases, then direction is reversed. So soft iron core upon which this primary or secondary coil is wound gets magnetized, then demagnetized, then again magnetized, then demagnetized. So it covers a hysteresis loop. It traces a hysteresis loop whose area is equal to the energy loss. So it will be discussed in magnetism. So to avoid hysteresis loss, we can use laminated soft iron core, or we can avoid minimize eddy currents. So, but there is some loss, that is known as hysteresis loss. Then fuming noise transformer also produce some noise, as a result some energy is wasted. Then transformer has so many uses. Transformer is everywhere, in your fridge, television, computer, everywhere you will find a transformer in all electrical appliances in our home. Transformer has a major role in power transmission from one place to another place, from one city to another city. At the generating station, how energy is transmitted, power is transmitted from one city to another city. No, where power is generated, so where is generating station? At a generating station, we use step-up transformer, and then through wires. Then where we have to receive power, we use step-down transformer. Now, what step-up transformer does? Step-up transformer increases voltage, say 220 volt to 22,000 volt, so that it reduces current. And when we have to use 220 volt at our home, our houses, so we have to use step down transformer. 22,000 voltage is step down to 220 volt. Why it is done? Because if we do not use transformer, we do not step up voltage at the generating station, so there will be large current passing through the wires, there will be loss of energy. So to avoid loss of energy, we have to use thick copper wires or aluminum wires. So there will be loss of energy, and there will be more cost of installation. So there are two benefits of using step up transformer at the generating station and step down transformer at the receiving station. Number one, it reduces cost of installation, because when we up the voltage to 220 to 20,000 volts, say, then current is reduced to a very small value. So heat produced by joule of heating is very, very small. So very small amount of heat is lost during this journey. But if we do not use transformer, so more current has to be passed through wires, more heat will be produced, and most of energy will be lost when we receive at the receiving station. So this is the major role. It reduces energy loss. Number two, it also reduces cost of installation. So thick wires will be costly. When we step up, so ordinary wires, thin wires will be sufficient for transmission. So use of transformer for long distance transmission is very, very important. Without step up and step down transformer, we cannot transmit energy from one place to another place. So this is the major use. So transformer is everywhere, in all appliances, furnaces, everywhere transformer is used. So this is all about transformer principle, construction, working theory, various energy losses, difference between step up and step down transformer, and uses of transformer. Transformer works on AC. Note, transformer doesn't work on DC, because DC will be constant, it will not change. So it is based upon principle of rate of change of magnetic flux. So that's why transformer used in AC circuits only. So all the best, be happy, stay tuned for next video. Good luck.